Hey everyone, welcome back to the channel. Get ready to dive into one of the most intriguing and, dare I say, mind-bending astronomical mysteries of our time. We're talking about an interstellar visitor, a comet called 3I Atlas, and the incredible speculative insights from none other than Harvard astrophysicist Avi Loeb. Buckle up, because things are about to get really interesting. Now, you might remember Avi Loeb from his work on Oumuamua, another bizarre interstellar object. He's not one to shy away from unconventional ideas, and he's brought that same audacious spirit to 3I Atlas. He's highlighted what he calls 8 anomalies surrounding this comet, and at one point even pointed to October 29th as a key date, playfully suggesting it's better to take a vacation beforehand. What in the universe could he possibly mean? Let's start by understanding what 3I Atlas is. It's an interstellar comet, meaning it originated from beyond our solar system. We've only seen a handful of these, and each one offers a tantalizing glimpse into other star systems. But 3I Atlas in particular has been a head-scratcher. Comets usually behave in predictable ways. They're essentially dirty snowballs, and as they get closer to the sun, their ice sublimates, creating a beautiful tail. Simple, right? Well, not so much with Avi Loeb, ever the meticulous observer, has identified these 8 anomalies that make 3I Atlas stand out from your typical celestial wanderer. We're talking about things that just don't quite fit the standard comet model. Let's break down some of these points. First, its trajectory. While it is an interstellar object, its path wasn't perfectly straightforward. Then there's its behavior as it approached the sun. Instead of a consistent brightening and tail development, it showed some peculiar changes. Imagine expecting a steady light, but instead, it flickers in an unusual pattern. This kind of behavior can hint at unexpected physical processes happening on the comet's surface, or even within its structure. Another anomaly concerns its fragmentation. At 1.3I, Atlas started to break apart, which isn't unheard of for comets. However, the asterisk way asterisk it fragmented and the asterisk timing asterisk of it raised some eyebrows. It wasn't just a simple disintegration. There were details in the breakup that made scientists wonder if something more complex was at play. Loeb also questioned its reflectivity and composition. What was it made of? Was it truly just ice and rock, or was there something else reflecting sunlight in an unexpected way? These details, when viewed individually, might seem minor, but when you pile 8 of them together, they start to paint a picture of an object that's anything but ordinary. It's like finding 8 strange clues at a crime scene that don't quite fit the initial theory. Now, before anyone gets too carried away, Loeb himself readily admits that 3I Atlas is asterisk, most likely asterisk, a natural object. The universe is full of wonders, and sometimes nature just throws us curveballs. These anomalies could simply be due to unique natural conditions, perhaps a composition we haven't fully understood yet, or a specific interaction with solar radiation that we haven't modeled. Our understanding of interstellar comets is still in its infancy, so every new visitor teaches us something new. However, and this is where it gets exciting, Loeb frames his approach as a pedagogical exercise in speculative physics. He's challenging us to think beyond the conventional. He's asking, asterisk, what if it isn't? Asterisk, what if these 8 anomalies collectively point to something artificial? It's a thought experiment designed to push the boundaries of our imagination and scientific inquiry. It's about asking the big questions, even if the answers are likely mundane. This is how science progresses, by questioning assumptions and exploring possibilities, even the far-fetched ones. His provocative suggestion about October 29th being a key date and the advice to take a vacation beforehand was a playful, albeit attention-grabbing way of highlighting that around that time, crucial data about 3I Atlas was expected to become available. Scientists would have more observations, clearer images, and better spectroscopic data. This information would either confirm its natural origin or, in the incredibly unlikely scenario, bolster the something else theory. So, what exactly would finding out entail? If it were something artificial, what would it look like? Loeb suggests that an object could be engineered to appear like a comet to avoid detection, a sort of cosmic camouflage. If it were artificial, its fragmentation might not be random but deliberate, perhaps releasing probes or components. Its unusual light curve could be signaling, or the result of propulsion systems. Again, these are highly speculative ideas, but they're part of that pedagogical exercise, teaching us to keep an open mind. Ultimately, the data from around that October 29th timeframe and subsequent analyses have led the scientific community to largely conclude that 31ATLAS was indeed a natural comet, albeit a very peculiar one. The fragmentation was attributed to its volatile composition and structural integrity as it approached the Sun, and other anomalies were gradually explained through refined models and more comprehensive observations. It turns out the universe still has plenty of natural surprises up its sleeve. But here's why Avi Loeb's approach is so valuable, even when the extraordinary explanation doesn't pan out. He sparks curiosity. He encourages critical thinking. He reminds us that true scientific discovery isn't just about confirming existing theories, but about being brave enough to challenge them, to consider the improbable, and to push the boundaries of what we think we know. It keeps us sharp, it keeps us innovating, and it prevents us from becoming complacent. His work, even when speculative, serves a crucial purpose. It inspires a new generation of scientists to look at the universe with wonder and a healthy dose of skepticism. It pushes engineers to develop better instruments to gather more precise data. It prompts theorists to develop more robust models to explain these celestial enigmas. And for us, the curious public, it offers a thrilling glimpse into the cutting edge of astrophysics, reminding us that there are still so many incredible mysteries waiting to be solved. So, while 3I Atlas may have turned out to be a natural comet, the journey of understanding it, fueled by the bold ideas of scientists like Avi Loeb, was anything but ordinary. It was a fantastic example of how science grapples with the unknown, how it explores possibilities, and how it ultimately refines our understanding of the vast, beautiful cosmos. What do you think about Avi Loeb's pedagogical exercise? Do you believe it's important for scientists to speculate on unconventional theories, even if they're unlikely? Let me know your thoughts in the comments below. If you enjoyed this cosmic deep dive, please hit that like button, share this video with a friend who loves a good mystery, and definitely subscribe so you don't miss our next adventure into the universe. Thanks for watching, and I'll see you next time.